Okay, I'll start like this. Now the conduction, the word itself. So first, what is the heat transfer? So it will flow from higher temperature to low temperature. Already some discussion what we had in thermometry. Heat flows from higher temperature low temperature, from high temperature to low temperature. Heat is a form of energy. We know that. What is the heat? Don't say heat energy. Call heat is a form of energy, that one. It flows from high temperature to low temperature. Then who will support that flow? Who will support that flow? So for that, let me take a conducting rod. Okay, they say at one end, let me lit a candle flame. Okay, there's iron rod. Or if you, okay, first, okay, we'll take this one only, iron rod. Okay, initially, the candle flame is kept here. And so initially what happened, it will be of room temperature. You can touch wherever you want. After some time, if you touch this end also, this will be hot, no? After some time, this end will also be hot, that one. So the candle flame is not here. The candle flame is not here. So the only this part of this end of iron rod is what exposed to candle flame. Then what makes the other end also to become hot? In fact, the heat will flow. So who is responsible for the heat flow? The material inside the rod is responsible for the flow of heat. Okay, that one, the material. So what is usually a conductor contains? So if you go for a basic idea of a conductor, what conductor must have? So this is some very basic thing what you try to remember. So conductor, what will happen? Made up of ions or atoms. Each atom will donate one free electron. So that particular free electron, okay, donates, no? Yeah. So when an atom loses an electron, so it will become an ion. Okay, fine, this is, and next we'll have the free electron. So what will happen to this free electron? This free electron will be moving randomly like gases. So what is the state of it? It will encounter collision and it'll be moving like this here. So these are the free electron. And there's a very basic idea. What is the state of free electron? Free electron, don't put it in order, let it be random. So how many? Okay, 6 atoms. So each atom will lose 1 electron and that will become free electron. So what is this negative sign? Free electron moves randomly inside the material. What about the circle with positive sign? It's a ion. Ion, immobile and can vibrate about their mean position. Okay, fine. So this is about the, so what will happen to this? It as the temperature will increase, its vibration of atoms will increase, and also the random motion of the free electrons will increase. So I think what is the modern definition of the temperature? The degree of so like the degree of the random vibration of atoms about their mean position. Means how rigorously the atoms are vibrating. The measure of that is what? The temperature. If the atoms are having, if they vibrate rigorously, means if the amplitude of oscillation is more, then temperature is said to be more. That's what the modern definition says. Means you take a iron rod at 25 degrees Celsius, iron rod at 100 degrees Celsius. Iron rod at 100 degrees Celsius, what happens there? Inside that, the atoms will vibrate more rigorously than iron rod and at 25 degrees Celsius, or atoms in the iron rod at 25 degrees Celsius. So therefore, the measure of the rigorous vibration of atoms about their mean position is nothing but the, the temperature. So as the increased temperature happen, this vibration will increase. At when the vibration will not be there at absolute zero. I think not possible. Okay, let's not go for all that discussion, that one. And what happened to electrons? The random motion also will increase here. This is called like a thermal agitation. Means they'll be vibrating. I think it's very simple. You same thing. Some 50 students are sitting in a room, AC room. Okay, they'll sit comfortably. I'll remove switch off AC. In summer, I'll switch off AC. Outside temperature 50 degrees Celsius. So what will happen? The students, they'll start moving here and there. No, what is the reason? Thermal agitation. Due to heat, what happened? We don't sit properly. We can't sit uh, comfortably. That one will start moving here and there, here and there. That one. That's the meaning of thermal agitation. The same thing happens for atoms also. Okay, able to get this one. So what is the state of in conductor? The electrons, free electrons, I'm telling, moves randomly inside the material. This electron, it will encounter collisions and it will be moving randomly. These atoms, they'll vibrate about mean position. Then what makes the heat to flow from higher temperature to low temperature? If you look at the temperature here, T1 degrees Celsius, the heat will flow like this. H, let me call heat symbol, or Q, you take it here. So what makes, who will transfer this heat? Who will transfer this heat? And what we have is T1 greater than T2, because this will be hot, this will be warm end. So who will transfer this? How do that heat energy will flow? The heat will be transferred by the this vibration of atoms and the random motion of electrons. So here, this atom starts, first what will happen? This atom starts vibrating. This atom starts vibrating. Let me show that. So as it vibrates, what it do? It will disturb the adjacent atoms and it will also start vibrating. So like that, the vibrations open will be transferred from one end to another end. The disturbance, or you can say the flow of energy, starts occurring. And what about electrons? Electrons will be moving here. So how the electrons? Electrons will move towards right, towards left, but net flow will be towards right. So who is involved in transfer of heat from one end to, from hot end to cold end, or say hot end to warm end? The electrons, free electrons, as well as the atoms. How the atoms will transfer energy? By through its vibration. So the moment this will start getting heat, it will increase its vibration. And because there's vibration, it will disturb the adjacent atom. So this also start vibrating, this also start vibrating. So in this way, what will happen? The vibrations will flow from one end to another end. And here also the temperature starts increasing. Okay, I agree this. I think one very good example you can do in your home, but you be careful. Huh? LPG flame, all of you having idea? This is LPG flame. Okay, now here, if I keep a spoon, and let me hold it. Okay, let me hold it. Okay, this is. Okay, no. What will happen? Can you hold it like this only? So there's a spoon, metal spoon, not plastic one. Plastic one will melt. Steel spoon, I'll write it. Can you hold it continuously? I think after some 5 minutes, what happened? Though your hand is away, though your hand is away from the flame, so there's the LPG flame. So you can start sensing the hotness here. You can start sensing the hotness, but your arm or your fingers and this end of spoon is not in flame. Only this particular, this is what in frame, no? Or it, so to become hot, the heat will flow through the material of the spoon. So how do that will take place? Conduction will occur. The heat will flow from this bowl shape, from curved shape to the other end. Able to analyze here? The heat will flow from higher temperature to low temperature. How will transfer that? The vibration of atoms and the motion of free electrons. Okay, clear. So what is the comment we can write? Heat flows from hot end warm end due to vibration of atoms about their mean position and random motion of free electrons. Okay, it is what responsible. Okay, this is about the theoretical idea. So this process is called like a conduction. We have to study this in detail. Agreed, all of you? Okay, now we'll go for. See, we have to study this means what happened. We should try to express this in terms of formula. So we should bring one any formula. Means mathematically how to express this phenomena is what we should try. Let me shade like this so that, okay, there's a rod. Okay, let's go for. So everything in physics, what happened? First, we will make observation, then we'll express it mathematically. Yeah. Okay, let's take a. Okay, there's a source, a temperature T1, there's a sink, a temperature T2. We'll be using some terms. What do you mean by source? Which supplies heat and temperature of it remains constant. It will lose it, but temperature of it remains constant. So how it is possible? I think it's a LPG flame. So what will happen to LPG flame? It will continuously supply heat, but temperature of LPG flame, will it decrease? No. I think there's a difference between body, source, and the sink. So what is the body? If it loses heat, temperature decreases. And okay, this one. What about the source? If it What about the sink? If it absorbs heat, temperature will not decrease. I think you should be very clear about the body. Body, if it gains heat, temperature increases. Body loses heat, temperature decreases. Source, if it loses heat, temperature will not increase. Sink, source, if it loses heat, temperature will not increase. Sink, if it absorbs heat, temperature will not increase. Getting the idea, no? So what is a sink? Example of source will be candle flame, sun, heater coil, LPG flame. All these are examples. Please do remember, like a body and source. So things are totally different. Okay, next afterwards, sink. What do you mean by sink? Which absorbs heat and temperature of it remains constant. Example, water tank, big water tank. So water bath usually. So they will absorb it. It will not change. Or a good example, what atmosphere. Temperature of atmosphere will increase. No. Water bath. Okay, these are the some examples what we have here. Sink. Okay, this one. So what is the sink? Though it absorbs heat, temperature will not increase. What is the source? Though it gives out heat, temperature will not decrease here. Body, what happens? Similar. Go for calorimetry for the body. Same thing you can discuss here. Okay, this is about the rod. There's a rod. Like it's a conducting rod. Yeah, no. The moment I bring conducting rod in contact with the source. So what this, we will split up this into parts. So initially, okay, initially let the temperature of this be T naught. Okay, temperature of all the total rod, let it be T naught. Initially, this is what happens. I'll bring it in contact, initial. Now, what actually happens? So we know it's a rod and every material, so suppose a conductors will have mass, specific heat. So first what this element will do, it is in contact with the source. Here, what is the source? Here, let's assume that source, it will supply heat energy. It's at higher temperature. Here, the atoms will be vibrating. When I connect this source to the rod, the atoms which are vibrating, what happen will make the atoms inside the rod here, the first element, it will make the first elements of them to make it to vibrate. So initially they had some vibration. So T1 greater than, I can say T naught. Let's assume that one. So what will happen to this? As they are vibrating at high, they have more vibration than the atoms inside the conducting rod. Means the atoms in the source will have more vibration than the atoms in the conducting rod. So the moment when source comes in contact with the rod, the vibration will be transmitted for the like atoms of the conductor. They'll also start vibrating. And because of that, the heat will flow. So what is the direction of heat flow? Will be like this. Then what will happen to it? It will start, it will, as it absorbs heat, then what happens? Temperature of that will increase. Then this element is in contact. So the vibrations of this will be passed to this. So again, what happens? This element will draw energy from this particular thing. How it will be transferred? By vibration. So as these atoms acquire a higher vibration due to in contact with the source, similarly, these atoms, when they come in contact here, means this vibrating atom will make these atoms to also vibrate. So therefore, the energy transfer will take place like this. So this particular element also what happen now will absorb heat and its temperature starts increasing. So like that, the segments, better we'll call this one. So these segments, what do? First, this will absorb heat and its temperature starts increasing. And in the meanwhile, what will happen? It will also involved in transfer of heat. And this second element, what it do, or second segment, it will also absorb heat and its temperature starts increasing. And it will also permit some heat to flow because it is in contact here. So as this vibrates, this also start vibrating. Like that, these segments, what they do, first we'll give a name like segment A, B, C, D, E, F. So what segment A will do? Segment A will absorb heat from the source and its temperature will increase. And it will also give some amount of heat to the segment B. Segment B will absorb heat, and what it does, its temperature will increase, and at the same time it will allow some heat to pass through because it is in contact with the segment C. So like that, each segment, what they do, they'll absorb heat, the temperature will increase, then and they'll be involved also in the transfer of heat. So finally, at steady state, a steady state, I see this particular thing. So there's a final, or better call, so what will happen here? No longer further rise in temperature of this element. It will be only involved in transfer of heat. So as at one instant, what will happen, what we can call steady state, this segment A, no longer further it will absorb heat. It will be only involved in transfer of heat. What all heat it will get from source, it will just give to segment B. Segment B also, what will happen, no longer further absorption of heat. It will be only involved in transfer of heat. What we are going to discuss is this particular steady state here. And like that, what will happen? So that particular heat, what will flow from source to sink through the rod. Okay, getting this one? This will be, what about these temperatures? The temperature gradient will be established. So here, if you check it clearly, this is what happens. So when you check the temperatures, no, temperature of source will be greater than sink. Along the rod, there'll be a temperature gradient, means the temperature will vary from source to the sink. This will be a little bit difficult. So all this iron rod, all these segments are having same mass, same specific heat, and they can absorb heat from the source. Okay, this will absorb heat from the source. So its temperature will increase. So definitely, what do I expect? I expect temperature of every segment must be same. The answer is no. So what we, it is based on statistical analysis. It is beyond our range. That one. So just let's like a story. I'm giving information here. To prove this, we have to go for statistical approach here. So we have to get into the vibration of atoms, then random motion of electrons. Then there from that, I should bring an equation. I should show that the temperature will be a function of distance. The proof is beyond our reach, like a class 12. Okay, therefore I'm just concluding it. So just like a call it quantitatively, I'm just giving information rather than qualitatively. So at steady state, what will happen? Segments will no longer involved in absorption of heat. They'll be involved only in transfer of heat. But initially, what will happen? Initially, each segment will absorb heat from T naught. It will attain temperature TA. From like a segment B, from T naught TB. So initially, the temperature of rod is T naught of all points. We know that one. When I connect between source and sink, the different segments will acquire different temperature. No, this called like a lagged, properly lagged rod. What do you mean by that? No longer further absorption of heat will take place. Only the segments of the rod are involved only in transfer of heat. This is what our syllabus, which will be discussing. This particular phenomena is called as a steady state or properly lagged steady state. So one more terminology what we use. Properly lagged means each and every element has absorbed heat and attained one fixed temperature. Then they'll be only involved in transfer of heat here. So what is the conclusion we can make it here at steady state? At steady state, each segment is involved in only transfer of heat. Next, so the first point. Okay, we'll put it like this. Next again, a temperature gradient is established across the along the length, along the length of the rod. Temperature gradient, you can see T1 greater than T. And as we move from source to sink, what will happen? Temperature decreases. As we move from source to sink, the temperature will decrease. T1 greater than T2. So it's a very clear now. What is the steady state? They just absorb heat, finish. They just involved only in transfer of heat. This will be very strange question for a student like, sir, both are of same mass, same material. This is at higher temperature, this is low temperature. Why can't this absorb heat and attain temperature of this? No, it will not happen. Because here some quantum level discussion is what involved here. So which is beyond our reach. Practically, if you want, you can check it. No, the spoon which is in LPG flame and the spoon and the end of the spoon where you are holding, there will be a different temperature. It's for the nature's phenomena that is being proved mathematically, which is beyond our reach. So just steady state means just get information of this one. Okay, there's a flow of heat. No, I'm interested like this. There'll be flow of heat. So what is this arrow? Flow of heat here. So I wanted to learn, okay, this flow of heat on what all factor depends.